This will disappear very fast. This will disappear very slowly. So yes, this is least reactive. This is most reactive. Another way to look at it, you have hydrogen gas coming out. Remember I told you that we look at things that appear or disappear? So hydrogen gas is going to come out. Bubbles are going to appear. The one that gives you most bubbles per unit time. Not that it gives you more bubbles. It just gives you most bubbles per unit time. They are faster the way they are coming out. That is most reactive. So sodium will release most hydrogen, hydrogen in the least time. Iron will release hydrogen in the most time. Zyada time lega wo. It will be slower. So if it is slower, it's less reactive. But to answer the reactivity question, we first need to know how do they react, and that is displacement principle. Let's try another one. Do the same thing with water. Now, let me take copper as an example here before I move on to that. Will copper react? Not at all, because copper cannot do displacement with hydrogen. Why? A more reactive element displaces a less reactive in a compound. You have copper and hydrogen. Hydrogen is more reactive. Copper is less reactive. It cannot displace it. Reaction will not happen. So if the reaction does not happen, that also tells us something, that it is very less reactive. But there is one that acts like it is not reactive, but it is very, very reactive, and that is aluminum. Aluminum has a special case. Aluminum has a layer of oxide, and that layer is non-porous. We say non-porous. So aluminum has a layer of non-porous layer of oxide that acts as a barrier and doesn't let it react. So whenever you want to react aluminum, aluminum must be scratched to remove the layer before reaction. So make sure if you're going to react aluminum in any like reactivity series and all that, you have to first scratch it so that aluminum comes out fresh, the layer goes away, and then you see the reactivity, and you'll see that it reacts really fast. So if I did the same thing here, if I put aluminum in HCl, initially no reaction will happen. But if I scratch aluminum and then I put it there, it will react really fast. Okay, so we can use the idea that it releases more temperature. It does it in less time. It releases gas in less time. There are more bubbles per unit time. The solid disappears faster. All 5 of these methods tell us which one's more reactive, which one's less reactive. Okay. All right. Now we know which elements will react with acid and which one will not. Obviously, the one that are above hydrogen will react. So going back to the first page, let's see with metal. So reaction with acid. So this one's going to be really fast. Okay, violent reaction. That's the word that we use. This one is really quick. This one is less strongly. Okay. And it keeps going slower and slower and slower. Okay. So this continues to happen until this one, which is very slow. But you still have them reacting vigorously, reacting violently. So if I wanted to use those words, I could be like that, okay, these ones are violent, then this one is vigorous. And then I could be like, use the word readily maybe, okay? And then this is reacting less strongly or slow. So you could be like less strongly. So again, these words, these adjectives, they're just to tell us which one's more reactive, which one's less reactive. And then these have no reaction. Why no reaction? Because they are less reactive than hydrogen.